Hi everyone, and welcome to today's Chemistry Daily Booster, number 6 in our series. Do note that this is one of the advanced information listed topics for those of you doing the foundation chemistry paper, but higher tier folks, it doesn't mean that won't have any questions on your paper on these topics, because as we know, there is no content that will not be assessed on these papers. What we're going to do in this little booster is have a look at the development of the periodic table. Now, don't forget, you do get a copy of the periodic table in your exam on that data sheet. Hopefully you will remember to turn over and at least look at. What we're going to do is have a look to see how we got to that periodic table that we all know and love today. The key person to remember here is a guy called Mendeleev. Now, what he actually did was he considered 3 key bits of evidence in order to create his periodic table. First thing was he actually used the atomic weights of the known elements, or the atomic mass. And the reason he did that was because we didn't know atomic number in those days. So he had to use the atomic weight or the atomic mass because we didn't know atomic number. He then used knowledge of chemical reactions of the different elements and finally knowledge of the physical properties. So once he'd gathered that information together, he started to arrange them in order of increasing atomic mass. But he then worked out that certain elements reacted in a similar way and they had similar physical properties. So he then placed those into groups together. So that gives us a rather familiar structure, hopefully, to what we know today. However, when he was doing this, we hadn't discovered all the elements. And so when he was actually putting them in order of increasing atomic mass, there were actually points where an element would have sat in a certain group, but the properties didn't really mesh with the rest in that group. So he worked on the assumption that there was something we hadn't discovered yet that would go in that space. So what he did was he actually left gaps where he thought there was going to be an element, we just didn't know what it was yet. The other thing he did was he actually swapped a couple of the elements around based on their properties. So even though their atomic mass would have put it so that they went in one particular order, he actually then swapped tellurium and iodine around based on their properties to put the iodine in group 7. Now, it wasn't until 1913 that atomic number was actually discovered by a scientist called Moseley. So when we actually got to 1913, the work that Mendeleev had done in the past was actually proven to be right, because when we actually worked out the atomic numbers of all of these elements, they just counted up sequentially, and it proved that those gaps that he'd left were right, because we had obviously those gaps corresponding to atomic numbers that weren't there. And with the tellurium and the iodine, again, the atomic number supported the placement. The next scientist that was important is a guy called Ramsay, and he actually discovered the element argon back in 1894. Now, this was almost a bit of a surprise to everyone because nobody had predicted that argon existed or even anything like argon existed. And the next year, Ramsay discovered helium. Following on from that, then 3 other elements were discovered: neon, krypton, xenon. Now I'm hoping that we've worked out that these are all familiar to us because they are all from group 0 on the periodic table, the noble gases. And the reason no one had predicted their existence was because they're very unreactive, they're inert gases. So we hadn't seen them interacting with other things. So they're kind of like invisible, really. We didn't know about their existence because we'd not seen them do anything. So Ramsay, when he discovered these, suggested to Mendeleev that these gases should be in a group of their own, placed next to group 7, because they didn't really fit anywhere else. So it's a case of, well, we just need to put a group at the end there of these particular elements we've just discovered. So from all of that work, we then developed our modern periodic table. So we've based it primarily on Mendeleev's periodic table, with obviously the additions of Moseley and Ramsay. And what we have today is what we still use in your exams. So first thing, the elements now are arranged in order of increasing atomic number. That's a significant difference between what Mendeleev did and obviously what we know as true today. Next one is that the atomic number tells us the number of protons in an atom. And going back to our work from C1, we hopefully know that the number of protons is the same as the number of electrons when we're talking about an atom because it's neutral. The electronic structure is determined by the number of electrons present within any particular substance. And the electronic structure is going to determine the chemical properties. So what that does is it also backs up that idea of all of these elements in group 1 reacting a similar way, because hopefully we remember that group 1, all the elements have 1 electron in their outer shell. So they've got that similar electronic structure, which means they have similar chemical properties. Final thing to do for today then is head on over and have a go at today's quiz. You can find the link in the description below as well as here if you don't fancy typing it out. Don't forget to join us again tomorrow for our next Chemistry Booster.